Okay, let's take a look at the homework problems on page 473. This is about similar polygons. And number 7 is the one we wanted to look at. On the blueprint of the apartment shown, the balcony measures 1 inch wide by 1.75 inches long. If the actual length of the balcony is 7 feet, what is the perimeter of the balcony? Okay, well, one way we could look at this is to say, well, here's the real polygon. It's actually 7 feet wide. What would this length be? Because in order to find the perimeter, I'm going to need to know both of these sides, right? Okay, so could we set up a proportion? 1 inch over 7 feet. This over this should equal that over that, right? 1.75 inches over x feet. Okay. What are our cross products going to be? 1 times x. So we get x equals 1.75 times 7. And what do we get there? 1.75 times 7, 12.25. And what did we say the units were going to be on x? They were going to be feet, right? So 12.25 feet. Okay. Well, if x is 12.25 feet, that balcony is a rectangle, right? So that's going to be true, isn't it? So our perimeter is going to be 2 times 7. I got 2 of those, plus 2 times 12.25. We got 2 of those. So our perimeter is going to be 2 times 7 is 14. 2 times 12.25 is 24.5. So I believe we find our perimeter is 38.5. And what are our units going to be? Feet. And perimeter is just feet. That's just a linear distance around the outside. Good. Okay, the next one we want to look at was number 17 here. The dimensions of a 17-inch flat panel computer screen are approximately 13.25 by 10.75 inches. The dimensions of a 19-inch flat panel computer screen are approximately 14.5 by 12 inches. To the nearest tenth are the computer screens similar? Okay, and this is important, to the nearest tenth, because if you set up a proportion here, you're going to find that they're not exactly, the cross products are not exactly equal. But to the nearest tenth, could we say they're similar? So here's what we would do. We would basically compare the length to width in this screen and see if it's the same ratio as the length to width in this screen, at least to the nearest tenth. So in other words, if these are similar, then 13.25 to 10.75 should be the same ratio as 14.5 to 12. Okay, and let's see what we get when we do this. And this is, if you want, it's 13.25 over 10.75, right? That's another way to write that ratio. Let's see if that is equal to 14.5 over 12. Okay, let's see what we get for each of these. 13.25 divided by 10.75, and I get the length of the width to the length is, or the length to the width is 1.23. And they want to know to the nearest tenth, so I'm going to say that's 1.2. Okay. How about this guy? 14.5 length to width over 12 gives me 1.208. When I round that, I get 1.2. Okay, so they're not exact, but to the nearest tenth, are they similar? We would say, yes, they are. All right, then we want to look at number 23. They want us to find the perimeter of the given triangle DEF. So we're looking for this guy here. And they tell us that triangle ABC is similar to DEF. And AB is 5, BC is 6, AC is 7, and DE is 3. Okay, so basically, if they're similar, and I know the scale factor, I know the perimeter of this triangle here, don't I? Can I add up all those sides? If I add 5 plus 7, I get 12 plus 6 is 18. Okay, well, I could multiply the perimeter of this triangle by the scale factor to get the perimeter of the other triangle. How do I find the scale factor? Well, notice AB in the similarity statement corresponds to side DE in the other triangle. So, in other words, this side and this side should be proportional by the scale factor. So the scale factor I'm looking for is, since this triangle is smaller, I want to multiply by the scale factor 3 over 5. Okay, the ratio of this triangle to that triangle is 3/5. Because that way, that's a fraction less than 1. So when I multiply this by that fraction, I'm going to get a smaller perimeter, which makes sense for a smaller triangle. So the perimeter of DEF should equal the perimeter of ABC times this scale factor, right? So it should equal 18 times 3/5. And what is 18 times 3? That's 54. Divided by 5, it should be 54/5, or you might get 10.8. Good. All right, let's see if we could do the same idea here with 25. They want us to find the perimeter of CBH. Maybe I'll go ahead and highlight that here so we can keep our eyes on that. They want us to find the perimeter of that triangle, and they tell us that CBH is similar to FEH, okay? And that ADEG is a parallelogram. CH is 7, so they've got that labeled. FH is 10, FE is 11, and EH is 6, okay? So we can do the same trick here. If we can figure out the scale factor, then we can take this perimeter. What is the perimeter of this triangle? 10 plus 11 is 21, plus 6 is 27. We could multiply that by the scale factor, right? We could say the perimeter of CBH is going to equal the perimeter of FEH times the scale factor, okay? So we got to figure out what that scale factor is going to be. The only side that I know in CBH that I can compare to a corresponding side in FEH is side CH. So I'm just going to point out that that's the first and third letter up here. So I got to compare that to this side FH in the other triangle, right? And I can see that FH is the larger side, okay? So in order to turn this perimeter into this smaller perimeter, the scale factor I'm looking for is 7 over 10. 7/10. In other words, I can multiply anything in this triangle by 7/10 to get the corresponding side or perimeter in this triangle. If I wanted to go the other way, I would make that scale factor 10/7. I could multiply anything in this triangle by 10/7 to get the corresponding side or perimeter in this triangle. So let's go ahead and do that. The perimeter of CBH is going to equal this perimeter 27 times this scale factor 7/10. Okay, and 27 times 7 is going to give me 199, I believe. You better check me on that. 27 times 7 is 189. Yeah, see, that's why you never trust your math teacher. Always check your math teacher. 189 over 10, okay, which would simplify to, of course, 18.9. Okay, so the perimeter of this guy is 18.9. Notice that trick allows us to do that without having to solve a couple of extra steps using proportions to find CB and BH and then add them all up. You can simply multiply this perimeter by the scale factor to get that perimeter, because the lengths of sides and perimeters are both just linear distances. Okay, let's see if we can do the same thing with this last problem. I think this is the last one here, number 27. Two similar rectangles have a scale factor of 2 to 4. The perimeter of the large rectangle is 80 meters. Find the perimeter of the small rectangle. Okay, so here's my small rectangle. Here's my large rectangle. And my perimeter here is 80 meters around the outside. Okay, and the ratio of these, the scale factor is 2 to 4. Okay, so in other words, this perimeter is going to be twice as large as this perimeter. Okay, so, or you could set that up as your scale factor. Your scale factor is 2 to 4. You can say K is 2 to 4. If you want, you can simplify that to 1/2. And you can say I'm going to multiply, let's say the perimeter here, let's call this perimeter of A, we'll call this perimeter of B. The perimeter of rectangle A is going to equal the perimeter of rectangle B times that scale factor. So it's going to equal 80 times 1/2, and that's going to give you 40. Good. Okay, that's the homework problems on similar polygons. Guys, don't forget to watch my next video, which is going to be the homework problems on similar triangles.